Hello, our project is using the Kiro dataset in order to generate new sketches from existing ones. We used different type of data, the NDJSON files and NPZ files. So for the NDJSON files, we started with some pre-processing. So this is, for example, like the airplanes, and this is one airplane having like many strokes, and for each stroke we have the X and Y coordinates. So we added some padding and mask to have a uniform data to feed to our RNN model. So we did some visualization on NPZ data. This is an example, and on NDJSON files, and we could see that we had better data with NDJSON files. Even though NPZ files are better for our NN models, we had to stick with NDJSON ones, but we didn't get good results. We always got like a line or something, so our model wasn't really good. So we tried a different approach using generative adversarial networks, but we had a problem on Jupyter Notebook because we always ran out of memory. Even though we weren't using like all of our samples, we like used only a few of them, like 1,000 or something, and we still had problems. What we did was we needed GPUs, so we worked on Google Colab, and the first approach was using the simplified data, and we could run the code here, but we had like real limitations because even here we would get like a lot of times memory problems even with the GPU, so we had to really tailor our code and make it really simple in order to work. So here we didn't get good results. So you can see that this is an example of generation of an airplane, which is not good. So we tried a different approach using 256 matrix, where we put ones where we have like points for the coordinates, and we put zeros elsewhere, and we added like ones for the points that link like that should link like the points in a stroke. And we did visualization to see that our model our representation is good, so it was good. We have like an outline of airplane even though it's like just a bunch of points, but we also didn't get good results. Like we always got something like that. We got a lot of ones, and we didn't have a good representation even when trying different thresholds and different like parameters and stuff. So that's it.
We realized that the data we were initially trying to work with wasn't very good. It was really difficult and needed a lot of computing power, so we decided to work on something similar. And we took the example of socks because there are many sketches. Here's the data that we had initially, the socks drawings. At first, what we did is, since we have these drawings in PNG format, we kind of had to convert them to arrays of pixel values. And we created a CSV file called socks.csv to store these values, and then we used them. Here we can see a little example of how the visualization looked like. Then what we did is we created the generator for the GAN and discriminator, and we put them together, and what we had as a result was this. It's really bad. So we thought maybe that's because we have little data, 80 pictures. So we decided to do some data augmentation, and therefore we created socks augmented right here. And as you can see, there are some rotated pics, flipped photos, etc. So a lot more. And following the same logic, we could create an image that was also bad. Therefore, we thought that a good idea would be to try hyperparameter tuning, but unfortunately we didn't have enough time. So we will be exploring this in the future. Thank you.